So here is Unit 3 worksheets, and here are the pH ones right here. This one we're not going to do. Okay, so anyway, if you'd like some more practice on doing pH with answers, they're here. Okay, so let's continue on now with acids and bases. Again, remember, acids are any compound with an H disassociates off as an H plus ion. A base, it disassociates off as an OH minus. Now, the molecule for bases, there's a little more to it, but that's the basic definition. And the main thing I want to leave you with on that quick definition is just because it has an H doesn't mean it's an acid. Only if it comes off as an ion, it's an acid. Otherwise, it's hydrogen is the most common element in the universe. So lots of things have hydrogen in them. One of the early building blocks of the universe, assuming you believe that. Okay, so I introduced pH to you last week, and we're going to do some more pH related stuff here. So the pH is the negative log of the hydrogen ion concentration. So the way I usually do it personally is I just do the log, and whatever the answer is to the logarithm, I just negate it. If it's negative, I make it positive. If it's positive, or you can put that into your calculations, your flow chart, as well. But it's I don't think it's really necessary as long as you're aware that needs to be there. Okay. Another thing I want to go over quickly before we continue on is water. Remember, water is made up of an acid and a base together. That's why the concept of neutrality comes in, is because it's equal amounts of both. So when that water molecule becomes an acid, it's going to disassociate an H plus, and it's going to disassociate a OH minus. And the ratio is 1 to 1. 1 to 1. Okay. If you calculate that, concentration is 10 to the minus 7. So it's extremely weak acid and an extremely weak base. Now, the concept of pH comes into play in science and engineering a lot when you're working with really small numbers. So you don't have to do scientific notation as much. You just work with logarithms instead, housed as a logarithm. Okay, so if we take the negative logarithm 10 to the minus 7, that's 7. We take the logarithm, the negative logarithm of 10 to the minus 7 for pH. It becomes POH because we're dealing with a base. So pH is for acids, POH is for bases. They're related through the number 14. So if you know pH, you can automatically calculate pOH and vice versa. So frequently with acids and base problems, they'll ask you for the pH and the pOH. And once you calculate one, it's easy to get the other one. You just go through 14. Okay, so now also on Thursday, you all tried to calculate with your calculator some values. So make sure, in fact, let's do that again. Because your calculators do it two different ways, depending on the brand and model of your calculator. Okay, so find the remember now square brackets is a shorthand way of writing concentration in moles per liter. So what is the pH of a molar concentration of point 23? On that. So go ahead and work out using your calculator with your log. Also, pH and pOH don't have units, which is rare in science and engineering. Most of the time, no, all numbers have units. pH is one of them. It does not. Okay, using your calculators, make sure you can end up with 0.64. And before we go on, I need to fix it with using your calculator. I have an 84 or an 83 Ti. All you do is you hit the log, put the number in, enter. It depends, though, if you have a Casio, it does it differently. If you have other models of TI, you do it differently. So anyway, if you did not get this number, I need to work with you, okay? Before we go on, because I'm going to be doing some pH problems. And if you can't get your pH and logarithm to work on your calculator, we're going to be shake. Did everyone get 0.64? Hey. Okay, so we are going to talk about neutralization reaction. And neutralization reaction is So. Let's take HCl acid plus sodium hydroxide base. Okay, so yeah, whenever we mix an acid and a base, we end up creating a neutralization reaction. Now, the acid can be strong or weak, but it's got to be an acid. Can't be something with an H that doesn't dissociate. The base can be strong or weak also. You still have a neutralization reaction, and you still create water plus the leftover ions, which we call salt. So the H and the OH form water. What's left over? We've got a cation and an anion. Oops. Sodium chloride. So this is the salt. Now, again, salt is not just sodium chloride. Salt is in generic terms, a cation and an anion. The salt. Okay, so all neutralization reactions are like this. Now, sometimes with acids, particularly, you can have more than one H comes off as an ion. For example, sulfuric acid. So if we had sulfuric acid, sodium hydroxide. Now, is this first equation, is it balanced? Balanced. Okay. So we're going to have water plus sodium sulfate in this case. So sulfate is -2. So that means we need 2 sodiums to balance that -2 sulfate. Sodiums are +1 apiece. Okay, so to balance this, which is not balanced now, we need 2 of these to get the sodiums up to 2. And how many waters do we end up making? 2 waters. So let's look at this. We have 1 sulfate, 1 sulfate. We have 2 plus 2 is 4 H's. 4 H's over here. Oxygens that are not associated with this SO4, we have 2, and the water gives us 2. So it's balanced now. The names of these acids vary depending on how many protons or hydrogen ions come off. Sulfuric acid is a diprotic acid. This would be a monoprotic acid. One comes off, mono. Protic means proton. H plus has no electrons. It just has 1 proton. So frequently they'll say there's a proton donor as one of the definitions of an acid. Proton donor. H plus donor. H plus disassociates. Comes off. There are probably, in your next class, you're probably going to talk, depending on which one you take, 1A or 2A, you're going to come across 4 definitions of an acid or 2 definitions of an acid. Depending on which 1A is going to be more comprehensive than 2A regarding acids and bases. I forgot whether you cover that in 1A or 1B. I know in 1B you do weak acids. Weak acids are a pain to work with. The math is much more difficult. You've got quadratic equations to deal with, all this stuff. Strong acids, because everything comes off 100%, much more straightforward. Okay, so now the question is, now that we've balanced the equation, let's work with the monoprotic one because it's simpler. So let's work with that one. And let's put some numbers to this. Okay, let's look at 5 moles of HCl. And this is, let's say, 2 liters, 2 liters. So what kind of concentrations do we end up with? Okay, well, with an acid, we've got H pluses and Cl minuses. With the sodium hydroxide, we've got Na pluses and OH minuses. So what's the concentrations now of everything? First of all, we need, what's our total volume? 4 liters. Mix them together. However, we've got some stuff going on underneath the covers in a neutralization reaction. Because we are taking out H plus and Cl, excuse me, H plus and OH minus ions because they're going to react to form water. So they are no longer there in the calculation of concentration. So if we looked at this, before we mix them together, excuse me, look at the concentrations of each. Okay, so as far as Cl goes, we have 5 moles, 2 liters. As far as the H goes, okay, now did everyone see how I got those numbers? It's HCl, when it comes apart in a 1-to-1 ratio, if the concentration of HCl is one thing, concentration of its parts is the same. Now, that's not true with a diprotic or a triprotic acid. Monoprotic is much more straightforward. Okay, so because the concentration of HCl is 5/2, that means the H plus is 5/2 and the Cl is 5/2. Okay? All right, let's do the same thing over here. Okay, so sodium is going to be 4.5. Okay, using the same deal. Sodium hydroxide, 1 OH comes off, 1 sodium comes off when it dissociates. Okay, now let's dump these together. Let's So how many moles our volume now is 4 liters. So we've got HCl, chlorine in there. We've got sodium and OH in there. Got 5 moles of H 4.5 moles of OH. We mix them together. When we mix them together, what happens? We don't have 5 moles of H any longer. How many do we have? 0.5. Why 0.5? Yeah, we had 4.5 liters of OH, grab 4.5, excuse me. We had 4.5 moles of OH, grab 4.5 moles of the H and form water. So because we had an imbalance of H and OHs, what's left over? The H, because there's more of them, by how much? 0.5. How many moles of OH? Those are all used up. What about sodium? 4.5. And what's left over? Cl. How many of those we have? Those did not get used up. Spectator ion, just along for the ride, just holding a place for the acid and holding a place for the base. So that's the salt. Okay, so what is the new concentration of H within mixture now? Well, we know we have 4 liters as the volume of the new mixture. So we're looking at concentration of H plus. So how many moles we have again? 0.5. So So 0.125 moles per liter is a new concentration. So let's talk pH now. What's the pH of our starting solution? Well, we have to calculate concentration first. So 5 divided by 2 is 2.5 moles per liter. So what's the pH of our starting solution? Get your calculator out. Do the log 2.5. So the pH is going to be equal to 0.4, negative 0.4. What is the pH of our other solution? Now, do we have a hydrogen ion concentration in the other solution? No. So what are we going to use instead? We're going to use POH and then subtract that from 14. That'll give us, remember the pH and POH is related through 14. Okay. By the way, this is going to be similar to one of your take-home problems. Having 2 take-home problems for test 3. One of them's acid and base, but there's going to be solution. Okay, so the POH so 4.5, so that's 2. 2.25. So remember, POH and pH are related through 14. So we know the POH is minus 35. So the pH is going to be equal to 13.35. Everyone see, or got, yeah. Well, because the POH, which is minus 0.35, plus the pH is equal to 14. So I solve for pH.
You add the pH.
Because it, yeah, because it's negative.
When I add them together, I get 0.0478. Plus it's. This is negatives.
Of 14.
Mhm.
Because POH is related to 14.
It's.
One, the other. It's like you add your.
Because
So that concluded that they're both related.
it's a useful function. It's negative. Yeah, it's negative. Well, a good side. When you look at the 14, you put 0.3 into the 14. Oh, right. So it's you're trying to get that 0.3 to 0. To move it to the.
All right, are we all on 14.35? Now that's very, very basic. Very, very basic. Negative 0.4 is very, very, very acid. Let's see now what the new pH is after we mix these together. Still pretty acidic. Anything negative pH is very acidic. But we expected that because we didn't neutralize all the H's. We had some left over. Now we can also calculate concentrations of so we have 5 moles in 4 liters of Cl. doing is we're taking the 5 moles of CL. Yeah,
Like, entrance. 1, 2, 5, and what is the thing underneath the side? Under the M, we put M in this.
as opposed to little m, which stands for meters. So I want to make the molarity, moles per liter, really obvious. It's not little m.
Oh,
And on, when I'm typing, I'll boldface it as well.
so
So,
that thing underneath it just means like little M's.
no, it means it's uppercase.
But you have 0.125 M, and then the thing underneath it, that's what I'm talking about.
Yeah.
Uppercase or lowercase? Okay.
You need more for.
Gotcha.
And it's just to distinguish m's. That's the problem. Sometimes this stuff starts repeating. So you need some gimmick to make sure you know that it's not one versus the other. So when you're writing M, make sure you write an uppercase m and not a lowercase m. As you get into more and more science, this is a problem. When abbreviations start overlapping like this, you gotta be really careful the way you write them. Okay, so concentration of sodium. And that's gonna be 4.5.
Not right, like. 1.3 moles over there, that's so count as.
Concentration, yeah. This is an abbreviated way of writing moles over liters is M uppercase M. Also square brackets. Another shortcut way of saying moles per liter.
Oh,
See the square brackets over here? You'll see that a lot also. Okay, so that's kind of an involved problem. It only took up probably a page and a half of your notes. Okay, the one thing about this class, unlike biology, is things build and build every time we go to a new subunit. Keeps building upon prior subunits. Now, unit 4 is going to be a little different because it doesn't do that. It builds a little bit, but not numbers like this. So unit 2 and 3 are very closely related. Very closely related. Oh, and then when we did the pH here, we could have also done pOH. Just subtracted from 14.
For the.
I'm sorry, I just asked for it.
Yeah. And then you in the pH.
Which is the hydrogen ion concentration.
Oh, right.
These aren't hydrogen, they're sodium and chloride. That's why there's no pH for sodium and chloride,
That's right.
only for active and bases. So if you dump table salt in water, the water will still be neutral. It's not giving off H's or OH's. Yeah,
My pH was positive like that.
Thank you for that.
Did I not negate it? Yes, I didn't negate it. It's those devils in the details. Okay, okay, let's do another problem here. It's kind of interesting. This is gonna be a dilution problem only with. Okay, so. Okay. So we have 3 liters of water of acidic solution, pH of 4. Dump in 2 liters of water. What's the new pH? Yeah, remember pH is concentration. So what concentration are we starting off with? Well, we have to convert the pH to concentration. pH is going to be changing. Is the pH going to go up or down? Is this going to be a weaker acidic solution because we're diluting it? Okay, so pH of 4 is the same as 10 to the minus 4th. Remember, logarithms are just another way of talking about exponents. And it's the negative log. That's why it's a negative 4. Okay. So we've got 10 to the minus 4 moles per liter of acid to start with. Does everyone see where I got the 10 to the minus 4 from pH? Okay. However, throwing in, and that's in 3 liters of water. So now we have volume times concentration, that's equal to moles. Okay, so that's gives us 3 times 10 to the minus 4th moles of H plus.
10 to the minus.
from pH of 4.
Okay.
Okay, we okay so far? Concentration times volume, moles per liter times liters gives us moles. So now we know how many moles of H plus we have in that water. Now we're going to dilute that water 2 more liters. So our final volume is what? 5 liters. So we have so what's our new concentration? This is went from 10 to the minus 4 to 10 to the minus 5. So the concentration of H plus went down, which it should be going down, because we're diluting it. I need to know what the new pH is. I don't care about the concentration. What's the pH? So we have the concentration now. So now we take the logarithm of that, and that'll give us our pH. Huh? Times 10 to the minus 5 log. So that's going to be your negative log in your calculator of 60 times 10 to the minus 5. The new concentration, or the pH of the new concentration, is 4.22.
Well, I just 3.0 times 4 to the negative. About 6.0 times 10 to the fifth.
Yeah. Is that what you got?
I got 2.99998. Oh, never mind. It's just giving, it gave me the first answer that I told you, and now it's giving me 0.00006.
And remember on yours, you can mode, and you can move it over to on that.
Oh, okay. Yeah, yeah. So you press second and then you just.
And you can change something needs.
I know, you know that. Yeah, thank you.
All right. Okay, so let's go on. Are there any questions about this problem? This was a tricky problem. Okay, now this is going to be like your take-home problem, something like this, yeah. Yes. Entonces, okay. So it'd be 4.2 then. Yes, sig figs all over the place. All right, okay, so any problems or any questions about this guy? Okay, because this has got a lot of stuff buried in it. And you've got pH, solutions, dilution problem, like we did earlier in the unit. Converting back to concentration and converting to the new negative logarithms. Okay, there's one last thing I need to cover in acids and bases. That's something called titration, acid-base titration. And I'm wondering if I should just do that tomorrow. Because it's kind of a long. Yeah, let's do that tomorrow. Which is what your last lab is about, by the way, like acid-base titration.
Last from the class or last?
Hmm?
Last class, last level.
Of the class, yeah.
Okay.
That's for, double replacement today, Monday, Tuesday, and then we have, a stoichiometry lab the end of part of the week, and we have a gas lab at the beginning of the week, and we have the titration labs. All wet labs, yeah, double replacement. Okay, okay, so let's do a couple little review problems. And then tomorrow we'll launch into titration. Now titration, is anyone in here scheduled to do Chem 5? Seriously? Chem 5 is called quantitative analysis. The whole class is devoted to this kind of stuff. It's a very focused class. You take that after you take 1B or after 12, Chem 12. 12 is the OChem. And 5 is quantitative analysis. Okay, so let's do okay. So let's back up a little bit and do a simpler problem. Okay, we have 8.1 grams of HCl and a little over 3 liters of water. What's the pH? The idea here now is to calculate the concentration first before we can do pH. Okay, so concentration is in moles per liters. We have grams, so we got to go from grams to moles. Okay, HCl is, and Cl is it 35? So we're looking at 3646. Okay, so we have 8.1 grams. All over 3.1 liters. Okay, this will get us to moles, and this is our volume. You can do this in 2 steps or 1 step. Doing 2 steps, first you calculate moles, and then you divide that by 3.1. And how many sig figs is this?
4.
0.072 moles per liter. Okay, now to form pH. That's gonna be the negative log. Now, a couple things, pH in your body. Your body goes to great lengths to make sure your pH in your body is maintained at certain levels. For one big reason. Does anyone know why it's so important? Why does your body go to great lengths to make sure your pH is what it's supposed to be and temperature together? Yeah,
Much of potentially damage parts of your body, but also you need to have high enough pH in certain areas like stomach acid.
okay. There's something called enzymes. Enzymes do all the chemistry in your body. I'm gonna say all, I'll just leave it at 99% of chemistry in your body is done by enzymes. Enzymes are proteins. The problem with a protein is its shape is determined by pH and temperature. So if the shape of the enzyme changes, it doesn't work anymore. Inside the enzyme, there's something called an active site, which is where all the chemistry occurs. So when you change the shape, they call it conformation of the protein, that active site changes as well. So the chemistry going on inside the active site no longer works. For example, in your stomach, there's an enzyme called protease. Protease digests proteins. So if you're popping antacids all day, what does that do to the pH in your stomach? Does it stay at 2? Yeah, it doesn't stay at 2 anymore. But your enzyme protease wants pH 2. So by changing the pH in your stomach, you're messing up your proteases. They function, but not as well. That's called enzyme activity. Activity of the enzyme goes down when you mess up temperature and pH. Same with temperature. It's designed for 98.6. If you drink ice water with dinner, like most people do, they want ice in their water, it's going to bring the temperature down. So your enzyme digesting that steak is not going to work as well because the pH is not 98.6. Again, it's why your body goes to great lengths to maintain pH and temperature. Yeah.
So when I was working, a lot of people ask for like room temperature water, and that just like flipped my mind, and I always like ice in my water. And so what kept going through my mind was why don't they want ice in their water, like over and over again? But I don't know why. I don't know. People don't.
Well, now you have a reason. I bet you, and I bet you,
So,
I bet you anything, they didn't know a very good reason why. Some people are teeth issues, dental issues with temperature. So, the other part of your body is mostly neutral, 7.4. In most parts of your body, 7.4. So enzymes in other parts of your body are designed for pH of 7.4, not 2, like in your stomach. So the acidity in your stomach is 10 to the minus 2 moles per liter. And by the way, it takes off paint off cars. How do I know that? When I was in the Air Force, someone used to drink a lot. And more than once, I drank too much and once it was onto my buddy's car hood. And that's how I know stomach acid takes off paint, of course. Now, his car wasn't waxed very well. If his car was really waxed well, it probably wouldn't have hurt it. But his was like, no. And low-end airman's pay scale, so his car wasn't waxed. Anyway, okay, well, that's it for today. So one, who though?
Yeah.